Welcome back to our Python learning session. Today we'll be discussing two functions, classify and classifier accuracy. Let me go over the description of classify function. A classifier function that uses a theta and theta naught to classify a set of data points. Argument intakes are feature matrix, a numpy matrix describing the given data. Each row represents a single data point, theta. A numpy array describing a linear classifier, theta. A numpy array describing a linear classifier, theta naught. A real valued number representing offset parameter. This function returns a numpy array, ones and minus ones, which kth element of the array is a predicate classification of kth row of feature matrix using given theta and theta naught. If a prediction is greater than 0, it should be considered a positive classification. That is the explanation for classify function. How should we code this? We'll start by defining a list called predict label. This list will contain the prediction from our training data set. Secondly, we'll start going through the data points in the data set, in provided data set. Now, we have to decide what is considered as a positive classification and what is considered negative classification. We'll code for a positive classification now. If theta naught plus np dot matmul matrix multiplication feature matrix dot I dot theta, if it is greater than 0, then we will classify that as a positive, and hence we need to add number 1 in our list. Else we need to simply add, if it is less or equal to 1, we will simply add minus 1 to our list. We don't need to say that this is minus or less than 1. We'll just simply add minus 1. Now we'll return the arrayed version of this list. We'll do np will return this arrayed version of this list, and hence our classification function is complete now. Next, we move on to classifier accuracy. Once we classify, how do we know that what is the accuracy of the classification? For that, we need to write a function. The definition of the function goes like this: trains a linear classifier and computes accuracy. This classifier is trained on trained data, classifies accuracy on trained data, and valid data is then returned. Argument intakes are classifier, a classifier function that takes argument, feature matrix, labels, and keyword arguments and returns fair and fair not. Train feature matrix, a NumPy matrix describing training data. Each row represents a single data point. Val feature matrix, a NumPy matrix describing training data. It should be validation data. Each row represents a single data point. Train labels, a NumPy array where kth element of array is a correct classification of kth row of the training feature matrix. Val labels, a NumPy array where kth element of the array is a correct classification of kth row of the validation matrix. Quarks, additional keyword arguments to pass to the classifier. Example T or L. This function returns a tuple in which first element is a scalar accuracy of the trained classifier on training data, and second element is the accuracy of trained classifier under validation data. These are two. That's the definition of this function. How should we code this? We'll start by coding a decision tree on which classifier to use. As we already saw before, we have two classifiers. One is average perceptron and one is Pegasus. This is Pegasus, and before we also coded for average perceptron. We need to choose based upon which classifier is passed, and we need to code accordingly. Now let's code for that. If classifier dot name, it is the internal name of classifier, is not equal to Pegasus. Is not equal to Pegasus. Then theta, return theta and theta not. Then return theta and theta not. Okay, let's do this. Classifier is a function we need to call, and since it's not Pegasus, we'll pass only one keyword argument for this. Let me pass train data, train feature matrix. Secondly, let me pass train labels. Thirdly, let me pass the keyword arguments here. And keyword arguments is a T. That's what we want to pass, T. This is keyword argument we want to pass, and there are two keyword arguments. One is 0 and one is T. One is 0 and one is 1. 0 is a theta, while 1 is theta not. So let me assign them appropriately. Theta and theta not as like this. We are passing T when it's not Pegasus. But if it's Pegasus, we need to pass additional parameter called L, which is lambda, which is a learning rate. Same way, we need to pass something like this. Let me just copy everything. It'll be easier that way, Now we have this. Now we need to add one more parameter for learning rate, or L. So So we have these two parameters that's being passed. How do we do this? Now we have fair and fair or not based upon the classifier we chose. Second step is to classify using this function and get the predictions out of them. So let me do this. Let me get a prediction out of them. Train prediction from classify using classify function we defined earlier. Classify train feature metrics theta and fair or not. These are two things we did. Train prediction. Second is valid prediction. Val prediction. This is a prediction for vals validations. Same thing, but we'll just change the train feature metrics with something else here. That's going to be val feature metrics. Now we have the predictions. Next step is to get the accuracy, and for that we need to implement we need to use accuracy function which we have already which has already been implemented for us, and we need to pass train prediction here. Also we need to pass train labels, which is a labels which is a truth for this accuracy, and let's assign the result as train act. Similarly, we need to do same thing for validation set data set. It's going to be val. It's going to be val and val preds and then val labels. Now we have the accuracy. We need to simply return these two values to the outside world: train act and val act. Now we have implemented these two functions. Let me quickly summarize what we did today. We created two functions. One is classify, one is classifier accuracy. Classify classifies a given data set and produces a predicted label array, and classifier accuracy uses set of predicted labels and the ground truth and compares them and calculates the accuracy of the classifier. That's all for today. I will see you in next learning session. Thank you so much.